In this lab, we will use a sun-based plot to show a relationship in the household trouble survey of your choice. Household trouble survey data frame has columns: household ID, household structure, dwell type, on dwell, household INC group, household size, years lived, total bikes used, total vehicles, adults age 5 to 18, tertiary education, secondary education, primary education, full-time, part-time, casual, total work, total trips. And let fig equal px. Px is plotly.express library. px.sunbased bracket the name of the data frame, df, comma, path equal bracket will have from dwell type to on dwell, comma, values equal household size. So the values that are shown is household size. So the size of each of these sectors are measured in terms of household size. Color equal household size, and color underscore continuous underscore scale equal eyes. Fig.show opening close bracket. So we can see that the dwell type separate house has the owned dwell owned, being purchased, rented, and among the separate house the household size about 2 to 3 is in the owned dwells, and being purchased his household size from about 3 to 3.5, and rented his household more than 3.5. So it's smaller the household size, and it is for the owned houses. We can see that for the terrace townhouse, the owned houses has household size about 3 to 3.5, and none of these has household size 1, but there is 2, and that's for the rented apartment or flat. Finally, let's try a sankey graph. So a sankey graph, so the sankey diagram, this is the website in Wikipedia. So it's a flow diagram. So the sankey graph, you can find more information in this website, https://n.wikipedia.org/wiki/sankey_diagram, which is often used to show the flows between entities. We plan to plot the number of cars from original country to each TLA in New Zealand. First, we need to use group by aggregate bracket count to find the number of cars from each country, original country, to each TLA. So let's display the column names of the cars data frame. So the cars data frame has columns basic color, body type, CC rating, first New Zealand registration year, FESH New Zealand registration month, gross vehicle mass, import status, industry class, make, model, motive power, number of axles, number of seats, New Zealand assembled, original country, power rating, previous country, submodel, TLA, transmission type, vehicle usage, vehicle year. Group cars data frame by original country and TLA. Pandas.data frame of cars data frame dot group by bracket square bracket original country comma TLA dot value underscore counts open and close bracket. So we have original country Australia, TLA is Ashburton district, and the value counts that gives basic color body type, so it divides um, rest of the variables and it counts. Let's group cars data frame by original country and TLA and the count. So let X list equal the cars data frame dot group by bracket and square bracket original count comma TLA dot close the brackets dot aggregate that is shown by IgG. In the bracket we will have count, and then we want the body type to be counted, and we get this. So for Australia, original country equal Australia, TLA equal Ashburton, the number of body types is 2. For TLA equal Auckland, the number of body types is 10. For TLA equal Christchurch City, the number of body types equal 5. For TLA equal Dunedin City, the number of body types equal 1. For TLA equal Far North District, the number of body types equal 3. For the original country United States, TLA equal Christchurch City, the number of body types equal 1. For Manawatu District, the number of body types equal 1. For New Plymouth District, the number of body types equal 1. For South Taranaki District, the number of body types equal 1. For Southland District, the number of body types equal 1. In total, there are 295 different counts. Let's convert the group by series to data frame. Let X list equal X list dot to underscore frame open and close bracket. So we have X list looking like this. So it's now in the data frame. Then let's convert these indexes into columns so we can use them in sankey graph later. So at the moment we have these columns has the index, original country and the TLA, and the body type is the column. So we want to have original country and TLA has columns. To do that, we pass the command xlist dot reset underscore index bracket level equals 0 comma in place equal true. So that converts the first so we have TLA left has the index column, but the original country, the first column, is converted into the column. Then we do another reset index to convert this index column for TLA into the data column. To do that, we pass the command xlist dot reset underscore index of level equals 0 in place equal true xlist That converts the TLA into the column data. The function below converts the data in the form above to a form of data that can be used in the sankey graph. But before that function, I will just manually show what we do. So color palette equal, let color palette equal these are the colors, and we put it in an array form. Let category columns equal original country and TLA in array form. For category call in category columns, print category call. So we have original country and TLA. X list of the category column dot values, and then we convert it to set, and then we list it, and we have this. Then for category call in category columns, print X list of category call dot values. So we have these values printed. For category call in category colors, print set of X list of category call dot values. So we had original country and TLA. So X list original country gives us the first set from Austria to United States, and for TLA it gives the second set, which is in from Waikato district to Ashburton district. For category calling category columns, print a list of set of X list category call dot values that gives in array form. For the first original country list, it gives Australia to United States. For the second TLA list, it gives from Waikato district to Ashburton district. Let color num list equal empty array. For category call in category columns, let label list temp equal list of set of X list category call dot values. Print length of label list temp. So the number of original country is 20, and the number of TLA is 63. Then let color num list equal empty set. For category call in category calls, let label list temp equal list of set of X list of category call dot values. Color num list dot append length of label list temp, and let's print the color num list. So we have, this should give 20 and 63 in array form. Let's look at the X list. Category calls is original country and TLA. X list of original country values is like this. Let label list equal empty array. Let color num list equal empty array. For cat call in cat calls, let label list temp equal list of set of X list of cat call dot values. Color num list dot append length of label list temp. Let label list equal label list plus label list temp. Let's print color num list, and then on the next line, let's print label list. So the color num list is 20 and 63. 20 is the number of original countries and 63 is the number of TLAs. And label list is the countries and the original countries and the TLAs all together in array form. Let's look at a list of dictionary dot from keys bracket label list, and that gives this. So it's a one value per line from Austria to Ashburton district. Remove duplicates from label list. So let label list equal list bracket dictionary dot from keys of label list, and printing the label list that gives from Austria to Ashburton district. Let's print the color num list, which is number of original country, which is 20, and number of TLA is 63. Enumerate of color num list gives like a function. So let's do for idx comma color num in enumerate color num list, print idx comma color num, and that gives index 0 is 20 and index 1 is 63. Color palette is this one. For idx comma color num in enumerate color num list, print color palette idx. So color palette 0 is this one, and color palette 1 is hash 306998. For idx comma color num in enumerate color num list, print color palette idx in array form, a number of is repeated the color num times, so that many colors. So let's print that. So the first the color palette for idx 0, that is repeated 20 times, and the second color is repeated 63 times. Let's define colors based on number of levels. Let color list equal empty array. For idx comma color num in enumerate color num list, colon let color list equal color list plus square bracket color palette of idx, and it's repeated color num times. So print color list. So we have color list this. So it's the it's all these two arrays. They are in one array now. Category columns are these. Transform DF into a source target pair for I in range of length cat calls -1. So we have category columns containing original country and TLA, and the length of it is 2, and 2 minus 1 is 1. So for I in range 1, that will give us 0. Category columns I, which is 0. Category columns I plus 1, which is TLA. Value calls equal body type. X list is TLA, original country, body type columns. Let source data DF equal X list of so we have category calls I is 0. So category calls 0 is original country, and category calls I plus 1 is a category calls 1, which is TLA. and value calls is body type. So X list of original country, TLA, and body type, and it gives us this table. Let's look at the columns of source target df dot columns, and that gives original country, TLA, body type. Let source target df dot columns equal source, target, and count, and that is in array form. So we want to relabel original country as source, the TLA has target, and the body type has count, and it gives us this. Let source target df equals source target df dot group by source and target. So we are grouping by source and target, and we are dot aggregate. So bracket. So we are using the sum, but we are labeling that column with count, and we will do reset underscore index opening close bracket to label each row with the index starting from 0 and for the number of rows. So for the source Australia, the target is Ashburton district and the count is 2. For the source United States, target is Christchurch city and the count is 1. Add index for source target pair. So source target df looks like this. Add index for source target. So source target df and the source column looks like this. It is all the original country. The label list has all the original all the country names as well. Along with that, the TLAs. So let's do source target df of source column dot apply bracket lambda x colon label list dot index x. So what happens is that source target df, for example, we have Australia, and Australia from the label list is in the index say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, index 14. So the it will be the value will be 14. And for United States, we have United States for the index row 290, and Australia is in 14th place, 15, 16, 17, 18, 19. So United States is in 19th place. So the value is 19. Search target df. So we have this, and now let's add the new source ID column, and that contains the values of the label list. Label list index, and that will be source ID. And for the target ID, we will look at the label list and we will find the label list index. For example, for Ashburton district, we will have Ashburton somewhere is the last one, very last one. So to add the target ID, we'll carry out the similar command source target df of the column target ID equals source target df column target, and we will apply bracket lambda x colon label list dot index of x. Source target df looks like this, and Ashburton district is the last one, which will be IT2 place. Creating the, now we have source ID and the target, the count, we need this. Creating the sankey diagram. Now we create the sankey diagram. Let data equal dictionary, open bracket, type equals sankey, comma, node equal dictionary, bracket, paid equal 15, comma, thickness equal 20, comma, line equal dictionary, color equal black, comma, width equal 0.5, close the bracket, comma, label equal label list, comma, color equal color list. So we have, we'll just look at the color list. And we have 83 colors altogether. So the first color is repeated 20 times and the second color is repeated 63 times. So link equal dictionary, bracket, source equals source target df of source id column, and target equal target id column, value equal count column, bracket. Now this layout equal dictionary, open bracket, the title equals sankey diagram, font equal dictionary, size equal 10. So dictionary of size equal 10, so we have only one parameter here. And now let fig equal dictionary of data equal in the array form, so data comma layout equal layout. Now we import the plotly dot offline dot iplot of fig comma validate equal false. So we have the source ID, which is all the original countries, and then we have target ID containing all the TLAs, all the districts in the New Zealand. And these dashes are the counts, that is the count of the body type. Now we have written a definition, this is a function, to do the similar function. So definition, gen sankey of df, comma, category calls equal empty set, comma, value calls equal empty space, comma, title equals sankey diagram. Close the bracket and then the column. And then we have all these function inside that, all these commands inside the function, and we retain the fig. Finally we plot the figure. So to plot the figure, we import plotly fig equal gen sankey, so we call this function gen sankey function, and bracket, the data frame is x list, comma, category calls equal array original country, comma, TLA, value calls equal body type, title equal imported cars, plotly dot offline dot iplot, bracket, fig comma validate equal false, gives us this. And what if we have validate equal true? We don't have to have import plotly again. and we don't have to have figure again because we have already defined the figure. Plotly.offline.iplot of fig validate equal true. And that gives us error. So it has to be false. It's pretty small, so let's export the plot into an external HTML file. Plotly.offline.plot of fig, validate equal false. The difference is we had iplot, now we just do the plot. And that creates the bit bigger plot. And we can see that for the source target equal Japan, let's plot this again. Okay, this pathway, source equal Japan, target equal 14, and count equals 17. Here the count is 12. So the highest count seems to be 17, and the source is from Japan and the target is to Auckland. And there are 17 body types.